Alright, so we looked at if we define L naught to be 1, what happens? We get the integers, right? So if L naught is 1, then we get the integers. Okay, but what if 1 is bigger than L naught? What happens then? Something very, very simple and beautiful, and which explains everything, happens. Because there's really only one sensible way to do this. Right, so we know that each interval is the same size, right? So the size of L naught is, L 67 naught minus L 66 naught, right? Whatever these two are, the distance, if they're 1 apart, right? So this is 67 and that one's 66. It could be 3 and 4, whatever they are, 1 apart. The difference between them is always the same as this interval, right? So it has to be a consistent interval, and the only way it's going to make sense is if it divides 1 evenly, right? Like, because you want, you can take the limit as x approaches 0, and you can take the limit as x approaches 1. So the thing just below 1 and just above 1 should be the same size as the thing that's just below 0 and just above 0. So it has to be the same size all the way across, from 0 to 1. Which means it has to evenly divide it. But you can also do things like, as x approaches 2/3, or, whatever fraction. So it has to divide all of the fractions evenly too. And this is where it's going to get into a problem. So, what happens if we try to look at all of the possible fractions, right? So if we look at the halves, right, and then we look at the thirds, well, in order to unify these, we have to automatically jump to the sixths, which means that we left in our wake the quarters and the fifths. But if we're doing the fourths and the sixths, then that means we're automatically getting to the 24ths, or the 12ths. Right? But then we also had, the fifths, so that gives us to the 60ths. So it ends up just being a problem that explodes in size. Right? You can't end this. Right? So, yeah, you can't have, it can't be rational. It's not possible because of this. L naught cannot possibly be rational, which also makes sense because you can take the limit as x approaches square root of 2, or pi, or phi, right? And it has to come up on those in the same exact way that it comes up on 0, and it comes up on 1, and it comes up on 2/3, right? So it has to approach it such that that final step up to it is the same distance away as every other step up to everything else. So we have to evenly divide all of the possible values, which is why it's impossible to ever reach this. That's why it's an infinitesimal, why you can't get to it. Because there is no way with division as your tool, well, with arithmetic as your toolkit, to ever actually get there. So either you end up with this being your situation, or this being your situation. Right? Either L naught is 1, and you have the integers, and any fraction with 1 in the numerator is nonsense, and any fraction with 0 in the denominator is just nonsense. They don't make sense. They're complete gibberish. Or, if 1 is larger than L naught, then it is necessarily the case that L naught has to be irrational and impossibly small. You can't ever access it. You can't ever get to it with the tools of arithmetic. And that pretty much, that gives you why 1 on L naught will be infinite. You can't ever get to that either with the tools of arithmetic.